Okay, hi everybody. Welcome to Rancher's January online meetup. Today we're going to talk about K3d, local development made easy with K3s. So for those of you who aren't familiar, K3s is Rancher's simplified distribution of Kubernetes. It seeks to have a smaller footprint, primarily through running as a single process, and an easier deployment and operations model because you just need a single binary to deploy to get Kubernetes up and running on a node. K3d is a wrapper around that that launches K3s clusters inside of Docker containers, and that's really what we're going to focus on today, is all the goodies that are in K3d and the different use cases it can solve. If you want more information on K3s, you can go to k3s.io. You could also check out our chief architect, Darren Shepard's recent meetup with the Civo Cloud folks. He did a nice, long, really deep technical deep dive on the internals of K3s. I recommend it. Who's here? My name is Craig Jellick. I'm hosting today. I'll note that typically these meetups are hosted by someone in our marketing or product management departments. They're way more qualified than I. So just bear with me, and I promise I'll do my best here. Okay, next we have Torsten Klein. He's the creator of K3d, and he's going to be doing the demoing today and kind of taking you through the feature set. And Alvaro, I'm not sure if he was able to join yet. He'll be on eventually. Alvaro is a contributor to the K3d community. Specifically has developed a plugin for K3d in vscode, and that's part of what we're going to demo. But Alvaro will primarily be audio only and just mainly here to help answer questions that come along. Okay, so let's go from here. First things first, this is a meetup, not a webinar. We always like to throw this disclaimer up front. What that means is a little bit different. The schedule isn't really set in stone. We booked 2 hours for this. It could be a little bit sooner, could be a little bit later than that. You can ask questions whenever you want. As Torsten is demoing, I'll pick out good questions for him to answer. Otherwise, I'll try and answer them just in the questions panel there. Honestly, anything you want to ask, please feel free. Lots of demoing. That's kind of the name of the game here. We'd like to demo sort of new things, even if they're not well polished or official products. In this case, K3d is a project. It's not even an official supported pay for type product anywhere. It's a project developed by the community for the community. And the last disclaimer we like to throw in is that things will break. Please be patient. Hopefully you'll see some pretty cool stuff here today. Other places you can go for information. This is probably the best one. Our Slack channel. There's K3s channel there. There's a K3d channel there that Torsten hangs out in and answers tons of questions. So please, if you have any questions, you couldn't get them answered here, or if they're bigger than that, we can. Sorry, if they take longer to answer, Slack would be the place to get them answered. All right. So the agenda is incredibly simple. I'm going to hand it over to Torsten here pretty quickly, and he's going to give you an overview of K3d, the feature set, and then demo a bunch of interesting things. I won't spoil the surprise on the things he's demoing. I'll let him talk through those. I already see one question here. Is K3d open source? The answer is absolutely. It was started open source. It will remain open source. It is available at github.com/rancher/K3d. And it also has a website at k3d.io. So yes, 100% open source. Okay, with that, I'm going to go ahead and hand it off to Torsten.
Hello there, and thanks, Craig, for the awesome intro. Small disclaimer, I'm on a Windows machine sharing a screen shared via AnyDesk on my Linux machine, because GoToWebinar only works on Windows and Mac, and I'm not familiar with those that much. So that's already the website that Craig told you about. It's k3d.io, the homepage of K3d, where you can find documentation, guides, an FAQ, pitfalls that you might stumble upon when using K3d and everything. I'm gonna switch my screen to a small slide I got from my internal talk at Trivago where I presented K3d. And I'm gonna jump right in with a bit of history, or why do I need this? So a few years ago, or like more like 2 or 3 years ago, I started with Kubernetes right after my bachelor thesis when I became a kind of DevOps engineer at Trivago. And my task was to move a development environment from a Docker Compose-based environment to a Kubernetes-based environment, or namely, back then it was Rancher 1.6 to Rancher 2. So then we had the one problem. We were always developing locally on our machines using Docker Compose, and everything was super nice and fast and everything. But when we switched to Kubernetes, our local development environment didn't really match what we had in production anymore. So we were searching for something that could get our local development environment as close to production as possible. And back then there was not that much out there. Minikube was already there, Kind was there, and MicroK3s just made its way out of Canonical, and they were all cool. But back then, for example, Minikube only had that one virtual machine backend, and that was super slow. Like creating a local development environment should be fast. They should be kind of throwaway style, so that if you screw anything up, you can just delete and rerun. So that was not an option back then. Kind was also in pretty early ages, and MicroK3s was cool, but not available on Mac and Windows because you needed it to be installed by a snap. Then while doing my usual work, which also contains browsing Twitter and Reddit, I stumbled upon K3s that was just released by Rancher. And I was like, damn, that's pretty cool. 5 less than Kubernetes, lightweight, can run on Raspberry. That's awesome. I gave it a try and it was so easy to use that I thought we could use this. But problem again, doesn't run on Windows. And I'm not even sure if it ran on Mac by then. I think not. Then I saw a guy named Rishab on Twitter who was tweeting about a project of himself called K3s in Docker, which was written in Rust. I gave it a try and it was super cool and unbelievably fast. And since it's Docker, K3s in Docker, it also worked on Mac and on Windows. So basically everywhere where there's Docker installed. It was missing some features though, and I'm pretty impatient, so I opened an issue and I talked to the maintainer, and since I wanted to get it done quite fast, I tried it myself. And apparently Rust was too hard for me back then, so I couldn't learn it in a few hours and implement the feature myself. So I just decided as a side project to rewrite that whole thing in Go, because also I just learned Go. It was my first real project in Go, and I thought it would fit great in the overall community of Kubernetes. So I did that, posted it on Twitter, and then Darren, the co-founder of Rancher, saw that tweet and messaged me and said, hey, let's collaborate on that. So we got also Rishab, the original creator, on board again, and we moved the whole project into the Rancher space on GitHub. And that's where it is now, and that's where it's evolving for, I think, almost 2 years now. Okay, I don't want to bore you anymore with history, so let's just jump right into where everything breaks, and that is demo time. On GitHub, I have a small repo called in my personal space, github.com iwill-try42 k3d-demo. You can go in there. It has a small README telling you what you will need if you want to run through all the demos in there. That it's Docker, K3d in the newest version as of today, Kubernetes just because I'm too lazy to type, and this handles context and namespace switching in Kubernetes for me. Chromium only for a demo, and Tilt and Drone for other development flows that I will show you later. Okay, switching back to my terminal windows. This is a 4-split terminal. In the top right, I will be continually watching all the containers running on my machine. Also stopped and exit ones. In the top left, I will do a kubectl get nodes that will always show all the nodes of the cluster that I'm connected to. Right now, it's nothing because the cluster you see here is doesn't exist anymore. And in the lower left, I will do a get all, so show all resources of the demo namespace. That should also not do anything right now because the cluster is not there. And in the lower right, you will see me typing and executing all the commands. I'm inside the demo repository, and everything that you can do there is basically achievable via make. So I have several make targets in there, and the first one I'm going to start with now is just make demo. This will walk you through a whole software development lifecycle with K3d. It will always, like this, show you a section title, what this is about. Then it tells you the step, the command that it's going to execute, so you can read through it, hit enter, and then we'll actually execute it just then. Let me make this a bit bigger here. All right, so now what I'm going to do is I execute K3d. I tell it to create a cluster. That cluster should be named demo. And I want to expose the Kubernetes API on my localhost's port 6550. I want to have one server and 3 agents. I want to map my localhost's port 8080 to port 80 on a load balancer. Every cluster that you create by default has a load balancer in front of it, which is mostly made for high availability clusters where you have more than one server node, so that you can kind of simulate killing one server node and then it should jump over to the next one for your kubectl connection and so on. But like this, you can also forward ingress traffic. Some people may already know this demo, but I can tell you there are more new things to come later in this meetup. So stay tuned. What I'm going to do here is I mount my current directory. You can do this with a pwd command as well. That's actually what it's doing there, just prints it. And I mount this to /src in all of the nodes that I'm going to create. And I wait for all the server nodes to be up and running before returning. This is actually by default. I already hit it so that you will see what's happening. It basically goes through some steps. It creates a Docker network for you with the name of the cluster that you chose. Then it's going to create all the containers that it will need, pulling the images, and then it's starting the containers. And by default, what K3d does, it's taking your default kube config, which is either under your home.kube/config, or whatever your kubeconfig environment variable points to. And it will add a new context there and switch to it. All right. So you already see in the top right, we have a few containers created. One is the load balancer in front of the cluster, which has port 8080 mapped from our host, from my host, mapped to port 80 on the load balancer, and exposes our Kubernetes API. Then we have 3 agent nodes and 1 server node. They're all up and running. And in the top left, you already see we have 1 control plane or master node and 3 workers up and running. And there's currently nothing in our demo namespace. Okay. Next, we check if we have access to the cluster. First, we tell K3d to give us a list of all clusters. And we see we have 1 here, 1 of 1 servers up and running, 3 of 3 agents up and running, and we have a load balancer. This could be false as well because you have the option to disable it, which, for example, makes sense if you are switching to host network mode. Then, next step is updating the default kube config with the new cluster details. This is already by default in the, oops, I forgot to update the demo script. Sorry for that. This is actually already done in the cluster create command. I just forgot to update the demo repository because this flag changed naming to --kubeconfig-merge default to more closely reflect the syntax that we chose for the overall CLI. I hope that doesn't happen too often. Next step is actually what we do in the top left already, checking the nodes with kubectl, still there, so the top left pane is not lying. That's good. Then we have a Docker file in this repository, which builds a basic, oh, let me check where it is. Okay, this is just building from Python, adding our code to it that we have here, which is a simple Flask application. It's installing the requirements, and it works in the /app directory. Okay, let's build this. Look at this build kit, is so beautiful. I could have done that before, that would have been more efficient. Anyways, okay, now the thing is we have built the image with Docker on my machine. So now the Docker daemon knows, oh yes, there's the image, but inside our cluster that we created inside Docker, we run K3s, which has its own containerd, container runtime. So now we somehow have to get the image from the local Docker into containerd inside the nodes. Luckily, K3d has you covered there. You just run K3d image import, then define which cluster you want to load it in, and a list of images. What it's doing now, you will see this in the top right, it will actually create another container. That container will mount a Docker volume that's shared with all of those other nodes. Then it will run a Docker save the tarball of the image into the shared volume, and then we will exec into every single node and run an image import. And we see we successfully imported that one image into one cluster. Now we are going, we're starting to use that image soon. So I create a demo namespace and I switch over to that namespace with Kubernetes. That's what I said before. Kubernetes is an awesome open source tool, which is part of the kubectx tool set, which you can download on GitHub. And it allows you to just easily manage Kubernetes namespaces and contexts. So I will quickly show that down here. KN is my alias for that, and it will allow me to interactively even switch through all the namespaces. Right. Back to that thingy. Then we have a Helm chart in our repository. It's on the sample conf chart sample app, and it's basically one single file. In the templates, it has an ingress, it has a service, and it has a deployment, which will be our Python Flask application. And then there's this part down here, which allows you to mount a volume from the host path into the container. And this will be interesting later on. I will tell you why. In the chart values, we tell it to use the image that we've just loaded into the cluster. We give it some variables. We say it should serve develops, so it should run, in this case, Flask instead of a production web server. And we want to expose this on the sample.k3d.localhost domain. And additionally, we want to mount a directory from the host, or rather the nodes, /src into the containers. I will tell you everything in more detail once we get there. So I run a Helm upgrade -- install to install that app into the demo namespace. And here we see pods created, and it's already running. We have the cluster IP service, deployment, and the replica set. Now, I will quickly also show you kubectl get ingresses, that we have the ingress here, sample.k3d.localhost. Now I'm going to open a Chromium window. Let's see if that works. I don't even know if I have it installed anymore, and browse through to that URL. So sample.k3d.localhost, our ingress domain, and the port 8080, which is the port that we defined when we created the cluster. Okay, now I probably have to, yeah, and there it is. Let me quickly move this to a different screen so that you can actually see it. There we go. K3d demo. And it's running on sample.k3d.localhost 8080. The cool thing here is that I didn't even have to modify my etc hosts to somehow fake a localhost connection in there, because the domain ends in .localhost. And on, at least on Linux systems, I don't know about Mac and Windows, there is a library called libnss-myhostname. You can also find that in the K3d documentation, which auto resolves all .localhost addresses into obviously localhost. So no need to put them into the hosts file. Okay, that's pretty cool. But now we want to do something else. I told you that we mounted a volume first from our host system into the cluster when we first installed, when we first set it up. Remember the -- volume flag of that directory, which is the demo repository to /src in all of our nodes. And now, since we are using a Python application and a Flask web server which supports hot code reloading, we can just go here and change something in the code. Like I go to the actual source code. Here I go, for example, to the settings, and I set the audience from something that it grabs from the environment to Meetup. And this should change whatever you see on the page there. So I hit save now, and what it should do is it saves to my local file system. That file system is mounted to /src of the nodes. And from there, it's actually mounted into the container through this volume mount, which mounts from the host path. And the cool thing is it mounts my app directly into the running pod. So when I switch back to the Chrome window now, you will still see the old one, K3d demo, hey Rancher, and when I hit refresh, it's hey Meetup. And that's pretty cool because I didn't have to rebuild any Docker image, I didn't have to push it, I didn't have to import another image. This is awesome. So for languages which support hot code reloading, this is kind of the fastest development flow that you can imagine directly on Kubernetes. Cool. Gonna close this one here. Now, growing the cluster. Now we developed an app and it's working pretty well on our small 4-node cluster. And now we want to see how does Kubernetes scale my application or whatever you want to test there. So we are going to add some nodes to the cluster, like you would probably do it with a real-world cluster as well. And you can do that pretty easily by running k3d node create nodes with the base name of new agent, attach them to the demo cluster. They should have the role agent, could be server as well. And I want 2 of those. I'm quickly going to, how did I do this? Yeah. Okay, now you see all of them again. Currently, we still have 4 nodes. And now I'm going to hit enter to add the 2 new agents. And that's basically it. What it does in the background is it goes to the cluster, checks if it can get a node from there. Then it basically copies the whole configuration of a node that has the same role as the role that you're targeting. and then it adds them to the cluster. And you already see up here, we have some more agents. They could even have a different image, actually. And when we run kubectl get nodes, we also see, yep, they're here, new agent 0, new agent 1, ready to use. Now we're coming to something that I heard from some people might be broken with later versions of K3s as of v1.20. We are running that, so let's see if it works. If not, rest assured it worked before. So we will be able to fix it again. Let's see. Let's say you want to go into break, but you don't want to waste all your resources on your machine, so you're going to stop this cluster. You just hit K3d cluster stop demo, and it will basically just shut down all of your containers. You see it up here, already in exited state, and at some point, kubectl get nodes and get all will start to fail, like just now. And we're done. You can try to access it. It will tell us, nope, not working. And now we can restart it. Just hit K3d cluster start demo. This is actually basically kind of the same thing as if you stop the Docker daemon altogether or you just reboot your machine. It will start again by default, unless you stop it manually. And here it actually works. I think that the bug might be with multi-server clusters and later versions of K3s. We are on that. Okay, we see all the nodes are back up and running in a matter of seconds. Cool, we stopped the cluster, it was on hold. I didn't waste my memory, I didn't waste my CPU in the meantime. Came back from lunch break and now I can say, yep, I'm finished. Let's delete the cluster, K3d cluster delete demo, and it's going to shut everything down. All the nodes are deleted, all the containers are deleted, cluster networks deleted, all the volumes and everything that it used. No trace left. And you saw in the beginning, it's a matter of seconds to actually create it again. Okay. I see that one question there, which says, can we start several different clusters? Yes, you can. Let me quickly demo that. Oops. We create the default cluster. By default, K3d will choose K3s-default as the name. Obviously, you cannot create multiple clusters with the same name, but that should be pretty clear. And then I can do K3 cluster create test to create another one. As simple as that. Now we have two clusters running here, and I can use kubectx to switch between them. So you see it here, K3d test and the K3d-K3s-default. Can switch to the other one, wait for it to reload, and you see everything is online. And I'm going to delete everything again. So I guess that question's answered.
I think we have a couple other good ones. Maybe you're going to get to them. One is there a way to configure a K3d cluster using a YAML file rather than command line arguments?
That's the next step. That's some next level stuff. It's actually landed just today in general availability with K3d v4.0, and I will show it to you in the next demo.
Cool. Next demo as in later today or next time?
Yes, later today. Like
got it.
Literally the next step I'm going to do now.
Okay, awesome. And then let me see if there are any other ones you should answer before you move on here. How can I update my K3d version installed?
If it's about K3d, you just run the install script again, or if you installed it via a package manager like Brew or maybe Chocolate on Windows, just run that again. And it should, if you run it now, it should actually pull version 4.0.0.
And then what about if you wanted to upgrade a clusters, like a K3d clusters K3s version side of it?
A clusters K3s version, you cannot update that one, actually. So the cluster is running. K3s itself supports like in-place upgrades, but since it's baked into the Docker image, it's not working. Actually, I haven't tried that myself, honestly, but I don't think that would work.
Okay.
But that's the beauty of K3d, is it's throwaway cluster. So unless you really need the data that's in that cluster, you just delete it and create a new one with a new version. Actually, that's something that I can show. Let me crypt it. Come on, Brew, what are you doing? That won't let me? Okay, thank you. So if you want to choose a different version of K3s that you're running, so by default, K3d bakes a default version of K3s into the program at runtime, at build time. So today I built version 4.0.0, and by that time, K3s 1.20.0-K3s2 was the latest stable version. So that's the default that we're going to choose. But you can as well create a cluster and specify whatever version you would like. 1.19.5-K3s1. That's a guess. I don't know if that exists, but I can try it. And then we'll just pull that, and it seems to work. Let's see, and create a cluster with a different K3s version. So that's that.
Cool. And then I think one more question before you move on is, how do you install the CNI using K3d? And I know that is tied into what K3s does with Flannel, but do you have any other, I guess, extra color to add to that answer?
More or less. So most CNIs can actually be deployed like any other Kubernetes resource with kubectl. By default, K3s comes with a CNI pre-installed, and if I'm not wrong, that's Canal and Flannel. And you can disable those via command line flags. So you pass a flag to the K3s server that basically disables the deployment of the CNI, and then you can deploy whatever you like on top of it. And that's all in the docs somewhere, or in our issues, or you can ask in the Slack channel.
Yeah, and it's just Flannel. You said Canal as well, but that is not baked into K3s. It's only Flannel that is.
That was the big brother RKE then. RKE1 at least, yeah.
Right, yep. Okay, here's one more. That's a long one. I'll read over it and then circle back to it later. So I'll let you go on with the demo.
Okay. So just here you see that I created a cluster with an older version of K3s. So you can choose whatever version you'd like. Now I'm going to the next demo part, and make target in this case is I could show you how to create a multi-server, but it's nothing else other than increasing the int that you put after the -- servers flag. That's actually one thing that changes internally. When you set the cluster init flag on a K3s server, it will switch from SQLite as the storage backend to etcd. So because etcd obviously supports multi-master configurations. And that's the only difference that happens in the background. Other than that, for K3d, it's just one flag and you increase the number of servers. So I'm going to run make demo config file, and that's a new one. That's actually what someone asked there in K3d v4. Came up with the support for config files. And as you can see here already, it's in alpha. So that's the first version of K3d that actually supports it. And it's the simple kind configuration file, also YAML format, which basically resembles all the options that you can set via the command line as well. No more, no less, just a little more human readable way of defining it. So I have this file here, which is also in the demo repository. Let me make that bigger. And yeah, using the v1 alpha 1 config version, style is simple. There's also cluster config, but that's kind of internal right now. And here we want to create a cluster named k3d-demo. Could as well be demo because k3d auto prefixes it with k3d as well. We're going to create a multi-server cluster with 3 servers, 2 agent nodes. We're going to expose the Kubernetes API on this super special IP of 0000, which is basically all interfaces on my local machine, and on port 6443. Actually, I meant to delete that. Seems like I forgot about it. We define which image of K3s we want to use. We mount some volumes, so some path from my local system to some path on all nodes. So node filters is everything that's referencing nodes. It can be all, it can be server 0, 1, 2, 3, 1, 2 in this case, can be servers, can be agents, or the load balancer. Then I expose some ports, like before, 8080 from localhost to port 80 on the load balancer, and 8443, so HTTPS ingress traffic to 443 on the load balancer. I set some environment variables, I set some Docker labels on the containers, and then I have some extra options that I can set. For example, making K3d wait for all the servers to be up and running. This is default. But also setting a wait timeout of 60 seconds. So if the cluster is not ready in a minute, then roll back. Not disabling the load balancer, just in here for completeness. All of this has default values. Disabling the image volume, we also don't want that. We pass in K3s extra server arc. This is, for example, where you would put, I think it's -- disable flannel if you want to disable the default CNI. You would put that here. In this case, we just put a subject alternative name for the TLS certificate. We don't pass agent arcs. And this is just repeating the default arguments for regarding the kubeconfig. That said, everything in here is optional. You don't have to specify anything. All of it has default values, just as if you would run K3d cluster create. And if you actually run it, you do K3d cluster create and reference the config file. If you specify any other flags, or for example, the cluster name, it will override whatever you have in your config file. So I'm going to do that now. I'm going to create a cluster using that config that you see here. Also see K3d says, hey, I'm using that config, and then it's doing exactly what we wanted. Creating the cluster, which has the name k3d-demo, which was a bit stupid from my side because K3d is already prefixed by default. And it's creating this. Didn't I say it was 3 servers? Might want to revisit that. And the 2 agents, at least that worked. Maybe I'm actually echoing the wrong file there. Okay, we run k3d cluster list. We see the clusters there, servers and agents are up and running. We will see if the kubeconfig was successfully merged. Yes, it is. Everything is up and running, ready for half a minute already. Seems like I'm talking too slow. So let's just clean up and we're done. Later on, I will show you some other examples of how to use the config file. What you can see now in the next step is we're going to use the same configuration, but this time we're actually passing in a name, and in theory it should override the name k3d-demo that is written in the config file. So let's see. Yep, does that, uses the config, but change the name to the override from the command line. Cool. and cleanup. So you see config file is still fairly new, and now I'm wondering if it's just not working properly. No, it's really saying 3 servers. So that's something, if anyone wants to contribute, please create an issue to remind me of fixing this. In the meantime, you can just pass in -s servers 3 from the command line to override that part. If you're gonna put a post-it somewhere. Okay, Craig, I don't know if you want to chime in with some questions now, or if I just continue.
Yeah, so I think here's a quick hit one. Is it possible to use multiple load balancers? And to be honest, I'm having a hard time parsing that question, but maybe you have, yeah, any thoughts?
I'm also not sure I get that, but I guess it's referring to the server load balancer that's created there. And quick answer is yes and no. So K3d won't let you just create multiple load balancers, like there is no load balancers 5 flags, but you obviously can just put some other Nginx containers there and have them reference the exact same thing. But still you would need one single endpoint that you can hit with kubectl, right? Or with your browser or with whatever. So I guess that's that. Don't
Cool.
know where it would make sense, but
Yeah. So the next one, I think every time you demo, I see this question come up. What's the repo link to your demo, since you put together such good reusable ones?
it's basically here. You can actually see it here already. I don't know if we will have some Meetup notes somewhere, but I guess if this will be put on YouTube, we can put it in the description, and I will put a whole link list there of everything that I use here. Basically,
Great.
it's github.com, I will try 42, my personal account, k3d-demo.
Cool. And K3d-demo. I'm just going to type it in there too for that person. Okay.
Yep.
And then let's see what else. So the long question was sort of almost a little more on the philosophical side, which is, is this encouraging development anti-patterns to a certain amount, because it's encouraging, to quote, use of local memory and CPU. And let's see, what was the other kind of part of that I wanted to hit? And doesn't that seem counterproductive for unit tests and the like? My personal take on this is that, and so what they're sort of pitching is, shouldn't you be provisioning a dev cluster through something like Rancher and then having devs connect to that remote dev cluster through kubectl? My personal experience is that's too long of a feedback loop for a lot of the things that I've worked on, and so where I've found value with K3d is just being able to really hack on Kubernetes, hack on the apps I'm putting into it a lot, not be afraid to make mistakes, because there's very little friction to starting over. It's just destroy the cluster and bring it back up, and that all happens within a few seconds. And so it allows for really fast iteration while you're doing local development. And then, after that is when you can get into dev test environments, pre-prod environments, that sort of thing. That's my opinion. I don't know if you have anything else to add there, Torsten.
That's actually exactly my opinion, and that's also why we were searching for something like that. It's first thing, you cannot break other people's stuff, but that also shouldn't happen in a properly designed dev cluster, so that's fine. One thing you have to consider though is, especially now in times that you have to connect via VPN possibly to your company network and so on, everything has to go via the network. So there are definitely solutions that also allow hot code reloading in a remote cluster, like I think Telepresence does that, by that it proxies traffic between your local machine and the remote cluster. But also there, everything relies on the network. So that's cool, and that might also work in many cases. In other cases, you will have to build the image, push it to some remote registry, have it be pulled into the dev cluster out there somewhere in the cloud. And that works as well, might just be a bit slower. K3d just gives you more flexibility. And it might not only be cool for developers, it might also be cool for operations people that just want to give it a try and want to see how Kubernetes in general behaves to different things that happen. For example, you create a cluster with 3 server nodes and 3 agent nodes. You deploy something on there, it's spread over the whole cluster. And with K3d, you don't need to shut down the whole server. You just go there and blow away one container or run K3d node stop and see how Kubernetes reacts, how it reschedules your pods, and so on and so forth. So things like that I also see on the side of K3d in this case.
Absolutely.
Same goes for Kind and all the others, obviously.
And then just to clear the docket here, the last question that we currently have is, does Rancher and thus K3s run on a Windows machine? The docs aren't clear to me on this. And so I'm going to answer half of that and then let you answer half of it too. Rancher, the multi-cluster manager project, is separate from K3s. Rancher supports Windows. The Rancher server itself, you deploy on a Linux server, but then you can deploy downstream Windows clusters. And those Windows clusters actually, I believe, they're based on RKE1, and they need to have at least one Linux node, I believe, for some control plane components. But then the workers can be Windows-based. K3s itself does not natively run sort of fully on Windows. We actually have a community member who's done a lot of work to kind of get it compiled and running on Windows, but it's sort of like a side effort. I wouldn't call it a first-class citizen by any means. K3d, Thorsten, have you ever played with running K3d like in WSL2 or anything like that?
I personally did it once, and just today, because I was trying to set everything up to actually do this demo on Windows, I actually struggled with the Docker installation, which was super weird, so I didn't do it. But I know it works. So obviously WSL2 is the preferred backend for that. So then you can even use the homebrew installation and the Linux binaries, but we also have Windows binaries, so you can run it in PowerShell, for example, and connect it to your Docker for desktop, be it Hyper-V backend or WSL2. And we have a community member, Nuno, who also created several blog posts on this and who's giving constant feedback. Thanks, Nuno.
And we also got someone confirming that they got K3d working that way just fine too. So
perfect.
Confirmation, good stuff. I think that's all we will answer here for now, and you can move on with your demo, and then we'll circle back to the new ones that came in.
Nice. Okay, so what we saw so far is a whole development lifecycle with K3d involving hot code reloading, and that was super cool. We also saw the config file, and it was super cool as well, even though some things were a bit off, but that's alpha, so that happens. Now there are some languages and obviously also web servers that don't support hot code reloading. And there your usual development lifecycle would look like you change your code, you build the image, you push that image to the registry, and then you pull it from there into your cluster. Or how we did it just before is you build the image and you import it into the cluster. Importing into the cluster is not always the fastest solution here because you have to import into every single node, even into those nodes which might not even be running the image after all. There are some awesome tools out there that help you with search development life cycles, for example, Skaffold or Tilt. And what they basically do is they watch your workspace, and if there are changes, you hit save, and it will automatically do the build, push, and redeploy steps for you. Up to now, Tilt had to go the image import route of K3d, but with v4.0, of K3d, we reintroduced managed registries. So you can create a K3d cluster which is directly connected to a K3d managed container registry. And we deploy a specific config map that's a Kubernetes standard by now, thanks to a community member, which Tilt will see. It will see this config map. From there, it will draw the details for the registry that was deployed with K3d. And so the cycle changes from importing the image to pushing the image to that one registry, and whatever nodes needs the image will pull it from there. And I also made a small demo for that, and that's actually super small. And maybe I will switch to vscode for that. Okay. So here I am in the demo repository, and I defined a tilt file. Tilt actually uses some Python variant of language. I just forgot the name, but basically this will just print something, and we are going to build the app, sample app in first case, and deploy our Helm chart. But this time we set the volume mount. We don't want to mount the source code into the pod because we don't want to do hot code reloading, but want to have the build push lifecycle. And the cool thing about Tilt is it will see that we are connected to a K3d cluster. It will go to the K3d cluster, grab that config map, grab the details about the registry that we created, see it, and directly push to that registry. Okay. And this is all behind make demo-tilt. We have a config file again for K3d, this time one server node, one agent node, and I know it will work. We name it tilt. We expose our the HTTP ingress, and we specify registries this time. We say we want to create a registry. This doesn't have any further config options. Everything created by this will be default. You can also set use and then put a list of registries there that you might have already created, and then we'll use those. But those you can create via K3d registry create and specify everything that you need. But this one create equals true. You cannot specify anything else. What you can do though is K3s runs containerd. Containerd has a special configuration for container registries, so you have to define mirrors. And K3s comes with a type or with a file called registries.yaml, so YAML file which kind of makes configuring containerd a bit easier. Now we assume the case that you have a registry running in your company, for example, some Artifactory somewhere, and you want to use that, but you also want to create a registry that's used by Tilt in your cluster or in Docker. Here you can actually define either an external file or you directly put it inside here. This says that this will be interpreted as plain text and read. Cool. So we're now going to create the cluster with that config. We expect it to be named tilt, expect it to have one server and one agent, expect it to have the port 8080 of localhost mapped to port 80 on the load balancer. We expect it to create a registry and have everything set up to push and pull from that registry. And we expect containerd to also know about this other registry hosted in the company. But we want Tilt to use the one that we created. So let's see. We're creating it. We see that we created the registry, k3d-tilt, like K3d default prefix, tilt cluster name, and registry. Starts the server, starts the agent, starts the registry, starts the load balancer. Okay, quick excursus here. We see the cluster, it's the tilt cluster. And now we inspect that config map I was talking about. Let me just delete all that. That happens when you're too lazy typing. and it will always be created in the kube public namespace and be called local registry hosting. Oops. Let's see what it looks like. It actually contains just the string data local registry hosting.v1, and it says from external, so from your host machine, the registry will be reachable via localhost 35849. That's a randomly assigned port. And from the container runtime, which is containerd in this case, it will be called k3d-tool-registry, which is the container name of the registry in Docker and the internal port. And then it has some help text. Now, when I run tilt up over here, actually, I don't know if I can make this bigger. Yes. It will go to the cluster that we are connected to, pull that config map and read this line so it knows where to push the image. All right, then let's see if that works. We run tilt up --registry. In this case means that we're running in terminal mode and not in the actually way cooler web view. Okay, we see it's running through the tilt file. It's building our Docker image that we referenced in the Docker file here. That may take some time. Actually, let me open the web view. That's just more beautiful. Okay, and we see it deployed our stuff so it built the image. It pushed the image to the registry on localhost 35849, sample at tilt specific tag. Then it injected that image into the Kubernetes YAML that was first rendered with Helm, and then deploys that. And we can see from the Kubernetes events that it sources that it pulled the image from the k3d-tilt-registry 5000, which is how the registry is perceived inside the cluster. We can also give it a try. Now, what was it called? I think sample k3 localhost 8080, right? And it's there, still with our change from before. Okay, now let's see what happens when we change the code again. This time I'm not actually going to change the code, but yeah, okay, sorry for that. I'm going to change some value here in, okay, it actually builds it now because I put the white space there. I'm going to change a value in my Helm file, and that's for the audience, which I have commented out here. I'm gonna change that back, Rancher Meetup, save that, and it will re-trigger the run of tilt, seeing it here in the web view, building the image, doing the Helm deploy, upgrading the deployment, and we already see from the logs from the application, it's there. And now if I refresh this, we should see the change, hey, Rancher Meetup. And yay, it worked. So it reacted to both the Helm value change and to the code change. Rebuilt the image, pushed it to the registry that K3d manages, and K3d pulled the image from there. And you see this also pretty fast, obviously not kind of instantaneous as with hot code reloading, but if your app or your language of choice doesn't support that, tilt is super awesome for this. If you don't have a registry, tilt will fall back to the image import functionality of K3d. And there are also other tools like Skaffold that can do the same thing. It's just tilt that I tried the first time today, and it was simple enough for me to get right on first try. And also it's pretty awesome that we have like only those few lines of config for it. Okay. I don't know if there are any questions here.
Yeah, I'm not sure if you'll be able to answer this one or not. How difficult or easy is it to configure X debug connections between PHP and IDEs? I assume that means PHP running in a container, part of a pod inside of a K3d cluster.
Yeah, I have absolutely no clue.
Yeah. Yeah, I
But
think that one might be a good one to take to Slack and see if anyone else has had experience doing that, I'll have to say.
yeah, thing is, I don't use PHP. I don't know Xdebug, and I don't know how it would communicate with the PHP app. I guess if it's via just plain TCP, or then you could just expose a port and
Mm.
do that. But I absolutely don't know.
Yep, okay. And then the other one we have here is footprint for memory and disk usage. How does that change per additional container? From the K3s side, in our docs, we have published in our docs some basic benchmarks around minimum system requirements for running K3s. That's in the context of, not in the context of K3d, that's just running K3s natively on a Linux host. But Thorsten, I don't know if you've ever done any sort of eyeball benchmarking of the resources that a K3d cluster takes.
I think we did it once when we created K3d to benchmark it against kind, but there it was just speed comparisons and not resource footprint. So I don't have a benchmark for that.
Mm-hmm. So
I
the
can
best.
say that, yeah,
Go ahead.
sorry. I can say that I can run like at least 5 or 6 clusters at every time on my machine without it dying. But it's also an i7 laptop with i7 and 32 gigs of RAM, so that might not be the pretty good benchmark there. But I don't think it will be a big problem. Where you can run into problems is when you try to run K3d on a Raspberry Pi, but that's also because already Docker is eating so many resources. Then you create multiple containers on there and possibly even have ports exposed, which in Docker means that you run another proxy and add IP table rules. That might break, but on every normal laptop, it shouldn't be a problem at all.
Yep. Okay, that's all the questions.
Cool. I would have one more quick demo, and then I go into demo the vscode extension. Actually, I would start with the vscode extension, put the other demo at the end, because that's about CI and not about development. So one thing to note for the overall meetup here and K3d is that K3d is in basics a community project. So it's completely community driven. It's not a real Rancher product. Yes, I do freelance work by now for Rancher, but K3d is still a community project. And so we love to receive pull requests. We love to receive issues. We love to discuss with you about what you like to have, what you hate about K3d, and everything. And there's one guy who did exactly that. It's Alvaro, and he's also on here as a panelist. And he created already 2 side projects which relate to K3d. He first contributed to K3d itself, and that was in K3d v1.6. He created the registry for the first time. That just now came back to v4. And he built a GNOME, or yeah, a GUI, which integrates with GNOME for Linux machines on K3d. That's kind of, I think, mostly deprecated now in favor of the new vscode extension that he created. So if I remember correctly, he just learned TypeScript, and this is his first project, integrating a K3d kind of configuration UI into VS Code. You can check it out by going to the configurations, Kubernetes K3d. That's his handle on GitHub and also in the Rancher user Slack. And it's in pretty early stages still, so please bear that in mind. It's also written here in the README. Has an awesome 5 of 5 ratings, so that's amazing. And I think that's kind of the first time that it's really published publicly. So I will quickly show you how it works. Basically, you can create K3d clusters right here with a few clicks. It depends, as it seems, on the Kubernetes extension for VS Code. You see it here in the sidebar. Kubernetes shows all my clusters for my kubeconfig, and make that smaller. And here under clouds, it will add a new icon or a new name, K3d. And there you can go, right click on it and create a cluster, or create a cluster with previous settings. So I'm just gonna hit that. Maybe I'm opening a terminal here. Quickly gonna delete that tilt cluster. And then I do a watch K3 cluster less, so we will see it in action. If you don't have K3d installed or any of the other tools that the Kubernetes extension needs, it will do that for you on first try. What it does now, I hit create cluster, and it goes to Docker Hub, to the rancher/K3s repository, fetch a list of images or image tags, which you see here, fetch 12 of them, and also lists some things that might already exist in K3d. And then it generates this nice cluster creation form for you. So here you can give a name. It auto generates one for you. You need at least one server. We can adjust that up and down, type a number. Maybe we create 2 agents here. Then we can choose an image for our nodes. And here we see the results of what we saw before. It was obtaining the list of images. So you get a nice and awesome dropdown here where you can choose a version. For example, 1.19.5 K3s 2. I hope that's one that I already pulled. This one I definitely pulled before. So I'm gonna choose that. Then you can choose to create a local registry. If you would already have a registry created, then you will have another one for using registry in a dropdown over here. And you can specify many more things, like the network, which is kind of hidden right now, and you have some advanced settings like I want the load balancer, I don't want it. Growable servers, it's actually a pretty cool feature. This is drifting off a bit, but anyways, when you create a single server cluster, that server will start with SQLite by default. So when you try to add another server node to this, it won't work because SQLite is not meant to work like this. If you create a cluster with several or more than one server node from the beginning, they will be started with cluster init flag. That means they will use etcd internally, which then you can add as many servers as you like. Just bear in mind you need a quorum. What growable servers does here is it actually appends the cluster init flag no matter if you have 1 or 5 or 3 servers, so that you will be on the safe side if you later want to add more nodes to it. I won't do this here. And then you can also add extra server arguments here. So now I'm going to create one cluster with one server, 2 agents, that image. Let's create a registry, and everything else I leave with default values. And I'm gonna hit create. It will show some output here. And I'm gonna switch over here so that we see what's happening. So obviously here the whole output that you saw before in the demos is hidden. Maybe I didn't pull that image. Yeah, I guess it still needs to pull the image. In the meantime, I can already show you from the commands tab, you also can type k3d, create cluster, delete cluster, and later on you can add nodes to it, delete them, or replace a cluster, which is pretty cool. It's basically refreshing an existing cluster. So deleting it and creating a new cluster with the same spec in its place instead. Basically refresh. And that's pretty cool. There are also some settings that you can set in the overall preferences. For example, I can choose which update channel I want to use for K3d itself. So when vscode or the extension pulls a new K3d release, you can use, for example, stable, so it only uses real releases, or all, then it will also consider pre-releases. Yeah, alpha and beta releases. Then under k3d.images, you have some options. For example, here you can define a regex for what image tags should be proposed to you in that dropdown when you create a cluster. Here I'm basically excluding the release candidates and non-GA versions. And there are many more options. You can see it here. You can set defaults, which is also pretty cool. For example, you can set defaults for every cluster that you create. All the settings that we saw before, but now as a default for every new cluster. It's that. You can specify the Docker host. You can specify an external K3d executable and all the configuration options for managing the kubeconfig. And there's much more to come if I understood Alvaro correctly. And please bear in mind, this is still in very early stages. And I honestly don't know what's happening. Okay.
Well, we warned everyone something would break, so no big deal here. I think the UX and sort of the ease of creating it is the really neat thing here.
Oh, that's what I tried it before and it worked perfectly fine. That's maybe Alvaro, you want to do some live debugging?
Yeah, well, I don't know. Yeah, it's failing, I guess.
I can promise you it worked before, and we see that it's also executing the correct commands. Might be something.
It's running the right command, right? I don't know if maybe you changed the binary, the K3d binary or something. Is it using the right binary?
Oh yeah, it's actually using my installed cluster, my system-wide installation instead of the vscode installation. So that might be the cause. Let's see what it does now. Okay. Install K3d. That's what I said before. Did I actually forget to pull the latest release or push the latest release? Okay, so it's pulling the GitHub release and installing it into the VS Kubernetes space. And there we go. Now let's try again. I will just leave everything with defaults and create the cluster. Oh. Ah, yeah, see, so that fixed it. So here we see we created the cluster and we see all the nodes inside the cluster, the server load balancer and the server itself. Now I guess K3d cluster list will also, obviously I don't have it installed. Stupid me, but you see it here and I guess that works. kubectl get nodes shows that one server that was created here, latest image version, and now you can also use the rest of the Kubernetes extension and actually expand this, see all the namespaces in there, see the nodes. Yeah, it's there. Everything is running on it. That's amazing. Now you can right-click the cluster. You can save the kubeconfig or merge the kubeconfig to whatever file you want, delete it, replace it, with a different cluster or even add an agent node. I'm going to do that because I didn't try that before. It works amazingly well.
Nice.
Guess that needs to refresh then. Yeah, there it is. Agent node is also there. Cool. Then let's try to replace the cluster. I guess it will give me the form again. Change the name. Servers, now this time I want 3. I don't change anything else and create the cluster. Oh yeah, we see it deleted the old one and replaced it with the new cluster that now has 3 server nodes but no agent. And then I assume should show up in here as well. So I guess that thing, yeah, it has to wait until the config was merged. We see all the output here in the background. Thanks vscode for actually not letting me close this. Okay. Yeah, this is all the debug output that you see when you're developing K3d. And we see it's close to finish. It always takes a little bit more time if you create a multi-server cluster because etcd has to learn all the new members and has to align and do leader election. And we see that it's finished because it pops up here in the Kubernetes extension with our 3 server nodes and everything running as expected. And now imagine you combine this in VS Code with the registry, with the tilt config as before, or with hot code reloading, and you don't have to leave your editor for anything. You can do basically everything via the Kubernetes extension, plus the K3d extension, and tilt installed, and you're ready for everything developing on Kubernetes. And that's pretty amazing. And a huge thanks to Alvaro and congrats for creating such an awesome tool. It's pretty amazing, especially for the first time TypeScript project. Good job there.
Yeah, I think it's great. It's such a easy, familiar UX to create and manage the clusters. I think it's a really cool workflow. I think a lot of devs will like it.
Yeah, it's amazing. Maybe. Yeah.
Good work.
No, not going to do it. Okay. So that's that. Any questions maybe on the VS Code extension? Because we also have the maintainer on here.
Yeah, I don't see, no new questions have come in yet. I think people are probably processing that a bit.
Mm-hmm. I'm also going to share the link to that repo and obviously to the extension itself in the notes if we have some. It's basically on here on the marketplace. It also has some nice overviews of how it works. Here you can actually see things that might have not worked before working. And the repo is under github.com. I don't know how to pronounce it, sorry, in Asia vscode-k3d. And I guess also there PRs and everything and issues are welcome. Did I miss anything, Alvaro? Anything highlight?
No, I think that you covered all the main things about the extension. Yeah.
Perfect. Awesome. Oh, here are also all the settings that you can use. Cool. Well then, thanks a lot for that, and I hope we can make it even greater. This is all exciting. I guess it's a welcome change now. Okay, I have one more thing that I can show off now that I created specifically for my talk in our Trivago Internal Tech Week, which is using K3d for something else other than local development. Actually, there's a question now popped in, probably. Will this work for remote development where the VS live in Windows 10 and the remote Linux systems?
I think that it depends on the support on K3d for using remote connection, right? Because that's something that I would like to implement at some moment to support SSH connections to the Docker host. So once we have that, we could support, running the extension in for example, in a Windows machine and running against a remote Docker daemon. That would be very nice, and I would like to implement that and to show that on the user interface as different clouds. So it would be good to have, for example, a local host cloud, K3d cloud. It's like it's not really a cloud, but and and we could have a remote Docker daemons being used as the remote clouds, and then we could do remote development. Yep.
Oh, that's pretty amazing. I think there might be two things to it, right? You can run K3d locally connected to a remote Docker daemon via SSH. That was what Alvaro just said. I think a different option would be to use the remote code extension and to run it in an SSH target, which has Docker installed. And there I actually don't know if that would work. I think that means that vscode is spawned on the remote host. And if the extension is also installed there, I guess it should work, right?
Yeah, it's not. I don't know so many details about the Visual Studio Code internal, but it's not. When you use that, you can run. Some parts are running locally, and the user interface is running locally. I guess that K3d would run locally too. I don't know. I'm not an expert on Visual Studio Code extensions, to be honest.
Okay. Yeah, cool. I guess that would be a nice proof of concept there. So
Yeah.
Alexis, who asked the question, you may want to try it and give feedback on the Rancher user Slack. That would be amazing. I would try it here, but all those SSH targets are out of reach right now, and the VPN connection will break everything. Cool. Then I only have one more thing to demo, which is running K3d for CI/CD. And this here I'm going to I created a proof of concept which uses drone CI because it's simple, and drone CI is already based on Docker containers. So every step is going to run in its own Docker container. So I created a super simple pipeline here. I actually don't use drone CI usually, so please don't hate me if I do anything wrong here. It's basically a basic pipeline of type Docker. It's called main. It's running on the OS Linux and ARC AMD64 platform, which kind of fits to my host system. And here I'm doing a cool thing. First thing to note here, Drone has plugins, which are specific Docker images that do specific tasks out of the box. And this is not something that this is self-made and could be transformed into such a drone orb or drone plugin. Okay, what I do here is I create a service, and a service in drone is something that always runs alongside your pipeline. Could, for example, be a Docker daemon that you can then connect to from the other containers that are running the pipeline steps. For example, here kubectl. In this case, I'm running a K3d SVC service. It's using one of our Docker images, which has K3d v4 bundled in a Docker in Docker container. So that's super inception here. We are running a Docker container, which runs its own Docker socket inside. And in there we run K3d, which spawns K3s, which runs containerd, which powers the Kubernetes cluster. So super inception. But anyways, it has to run in privileged mode due to it being Docker and Docker. And what it does is it starts the Docker daemon in the background. Then it waits until Docker daemon is up and running. And then it creates a cluster from a configuration that we specify in a YAML file. Here, it's a simple cluster, just one server node, and we disable some parts of K3s that we don't need. In this case, we expose the API on K3d SVC, which is the name of the service, and port 6445. Then we wait. This will automatically wait until the cluster is created and up and running. Then we have an extra step that waits for core DNS to be up and running in the kube system namespace. This is kind of fundamental because if you deploy something and DNS is not working, things might easily break. Then once that's done, we are getting the kube config from that cluster and writing it to a shared file. So a file that is shared between this service container and all the steps. And then we just chill around until this, for as long as the steps are doing some stuff. Okay, so now we have one container that is actually running a K3d cluster or a K3s cluster in Docker and exposes that to our steps. The steps, in this case, it's just basic kubectl. We have to switch to the root here because our image down here created the kube config as the root user because root is the default user in those Docker images, but Bitnami always changes it, and I was too lazy to search for a different image that uses root. Just as a side note here. And what this step does is it actually waits for the kube config to be written, which happens once the cluster and core DNS is ready. And then it just views the kube config, lists the ports, then it creates a namespace for our test deployments. Then it's actually going to deploy a pod on that namespace, which does nothing. Could imagine that as your application that you're going to deploy, maybe even via Helm. So your whole application is then running in the cluster, doing nothing. We wait for it to be up and running. Just another list for the demo here. And then we execute something in there, in that running pod inside the cluster hosted by that service. In this case, we just run a hello world, but you could imagine that you, for example, would try to execute some command there that will run integration tests for all the other services or whatever you'd like. Also, a cool idea that came to my mind is, for example, use Helm post-install hooks that wait for a job to finish, and that job could then run the integration tests and only succeed the release if all the tests passed. So then you could have a CI/CD pipeline that runs in Docker or in Kubernetes, which in turn runs another tiny throwaway Kubernetes cluster that won't touch any of your other infrastructure and won't harm anything else, and run all your integration tests on there. And once you're done, the cluster will just be deleted and there's no trace left anywhere of it. All right, let me show that to you. For that, you need the drone CNI to be installed. Inside our K3d demo repository, you can now run make demo drone, which is actually a wrapper around one single command, but that's fair enough. Shows again the config file for K3d that we're going to use. This is an important thing here, which is setting the certificate of the server container up to also be valid for K3d SVC, which is the name of the service container. And then service LB, local storage, and metric server are components that we just don't need for the sake of testing and makes the startup a bit faster. Okay, drone has a pretty cool feature which allows you to run a pipeline completely local because after all, it's just Docker containers. So I'm going to do that, execute the pipeline. We will see lots of code here now. Oh, maybe if I close this, you see my service container starts up and the kubectl container, which is the step, also starts. Down here we see at the beginning that our step is going into the wait loop to wait until the kube config is ready, while our service is actually running the dockerd entry point, creating the Docker daemon, starting everything up. this super long output, and then it's going to create our cluster. All the things that you already saw, some Docker stuff in between that we can safely ignore. And we see cluster is ready. So the service goes into the wait loop, waiting for core DNS to be up and running. One thing to note here is, again, this is a proof of concept. This could be transformed into a real drone CI plugin where all of this would be omitted and you just start your steps and reference the service. Okay, now we see service is up and running, core DNS is running, we write the kubeconfig to the shared folder, tell the user that K3d is ready, and wait for the end of the world to happen. In our test, we get out of the wait loop because we see, hey, kubeconfig is there, we can use it. Just print it here once. We see it references that service. It's our cluster. Yay, that's pretty cool. Let's see what pods are running there in all the namespaces. We see core DNS is already up and running. The install for traffic is taking its time for a bit, but in the meantime, we can already create our CI namespace for testing. Could as well run in default. I just put some steps here for the sake of demoing it. I'm going to run a test pod with an Alpine image and just let it stay there forever. Wait for it to be ready, up and running. Check it. We see, yeah, test pod is up and running for 6 seconds already. So we execute something inside that pod, and we only want to do echo hello world, and there we go. So this part could be run integration tests, or I don't know, curl my API.cluster.svc or whatever. Or you would replace that whole part with an Helm install and wait for the post-install hooks to finish so you know that your integration tests passed, and then you return success. And that's also what I wrote down here. So proof of concept, I guess this will work similarly for any other CI tool that you can think of. I just chose Drone because it has a simple config and uses containers anyway.
Yeah, and you stuck in the CLI and terminal here, but it should be mentioned Drone has a full UI and it can hook into GitHub workflows. So yeah. Like, you know, if you do a pull request, it'll let you know if your drone build passed or failed, that sort of thing.
Yeah, exactly. For example, this is a Rancher's drone instance, in this case, for the K3d repository. And this is the whole UI. Here you would have one field for the service running and then the steps. Exactly, and then you have Slack feedback and all the stuff that you need.
Yep, cool.
Cool, and that's about it. That's everything I could possibly show off today. Everything is here in the K3d demo repository and in vscode. And now I hope this was almost as exciting as the inauguration today. And now I'm open for questions.
Yeah, thank you so much, Torsten. This is great to see all this awesome work and these cool features of R02. You know, thanks for joining. And we'll wait a minute here, see if another question shows up or not. I think that's it. Again, Slack, Rancher's Slack channel is a great place to go for follow-up questions, or, you know, entering issues into any of these GitHub repos, be it K3d or K3s. Any of those are great. Yeah, I think that's all we have. Torsten, if you're good, I think we'll wrap up here.
Yep, I just commented somewhere where I didn't meant to comment. Sorry for that. Yeah, so everything's top from my side.
Sorry.
Thanks, Craig, for hosting this.
Oh, sure. We did get one question here. Is it possible to connect a local K3s cluster to a local Rancher running? And the answer to that is yes. So the easiest way is there's you can import a cluster into Rancher. So, start up Rancher locally, running as, for example, a Docker container, running, as a Docker container, and then create import cluster or register cluster. and then it'll give you a command to run, in the context, kubectl command in the context of your cluster, and that'll import it. So that's definitely possible. Yeah.
Yeah. Another thing to note also to that is that you can actually run K3d as a single node cluster in Docker's host network mode. And then you can even use it as a server where you can add external nodes, for example, your Raspberry Pi too. That's pretty hacky. It works somehow. Just saying.
All right. Well, thanks again, Torsten, Alvaro, and thank you all for joining, and have a great day.
Thank you to everyone. Bye.
Bye.
Bye.